Another way of checking out a signal is to compare data samples with values of our own. We compare two sets of values with each other by multiplying them together. Here's an example. Here we have a data sample set with the values 7, 2, -3, -2 and 5 in it. Let's call this data sample set little u. We'll call our test set of values little v. Let's suppose we've guessed the data samples correctly. Then little v is equal to little u. Multiply u and v together as follows. 7 times 7, 2 times 2, -3 times -3, -2 times -2, and 5 times 5. That comes to 91. This is called the dot product of u and v. To test if we have an exact match of the two sets, we work out the length of u and the length of v and multiply the two together. The two vertical lines mean the length of. The length of u is found by calculating the square root of u multiplied by itself. Like so. The length of u turns out to be the square root of 91. And of course we get the same result for the length of v. Similarly, the square root of 91. And of course if we multiply the length of u by the length of v, we obtain the square root of 91 times the square root of 91, which comes to 91, which is the same as the dot product u dot v. We have found that u and v are an exact match because the dot product of u and v is equal to the length of u times the length of v. Let's try out a different test set v. This time we'll use v consisting of 7, 2, -3, -1 and 5. This time the dot product of u and v is 89. The length of u remains the square root of 91, but the length of v is now the square root of 88. The dot product of u and v is not equal to the length of u times the length of v. In other words, the dot product is equal to 89, which is not equal to the square root of 91 times the square root of 88. In the next section, I propose to prove that the equality, the dot product of u and v, is equal to the length of u times the length of v, holds only if u and v are identical.